Hi everyone! So this week we had another story problem involving fractions. And yes, it's going to keep happening. Every Thursday we'll do a story problem of the week, and it will always involve some fractions. And I'm really impressed because a lot of you modeled, like you drew it out, or you realized, wait, we can add fractions together. What a cool concept. So even though we haven't explored this too much, it was a good exposure, I think, and sometimes it's good to challenge ourselves and try something new. So kudos to you for doing an awesome job on your story problems this week. I'm just going to go over each part really quickly, so this way you have an idea of what this might look like, especially in case you and your parents were a little bit frustrated or confused. It's always nice to kind of go over it together. So I wish you were here telling me how to do things. It'd be so much nicer if you were sitting in front of me, but instead of that, I'll just make this silly little video. Sorry guys, I have to talk to myself in my house. It's very weird. Alright, so I have the story problem right here. I'm not going to write it up on the board just because it would take too much time, but I'll read it to you and kind of talk through it and write down some of the important stuff. Alright, so part one. I've been doing a lot of baking. This is why I thought of the story problem. A recipe requires 3/4 cups of milk and 1/2 cup of butter. Miss Seminelli wants to quadruple, which means 4 times, the recipe. I'm going to do it 4 times. I'm not going to make it once, I'm going to make it 4 times. How much milk and how much butter do I need? So obviously, let me just write down the important parts. If I make just one version of this recipe, one batch, I will need 3/4 cup milk. And if I want to model that out, fun fact, I'm going to be very picky about this. Do not draw circles. Do not draw circles. It is very hard to draw circles with fractions. Draw rectangles. Say that with me one more time. Do not draw circles. Draw rectangles. Cutting up a circle is kind of impossible. So anyway, I'm just going to draw a visual model. It'll be a bar model, right? So I'm going to draw a rectangle. So 3/4, I'm going to cut my rectangle into 4 pieces, 4 equal-ish pieces. Sorry, I have a thing in my hand, 4 pieces. 1, 2, 3. And I'm going to shade in 4 of them. 1, 2, 3 out of 4 pieces. 3/4 milk. And it also said 1/2 cup butter. I'm just going to put it over here. So I'll do the same thing, draw my rectangle, 1/2, and shade in 1/2. So that would be just what I need for one recipe. If I want to quadruple this, let me just draw this 4 times, right? So this is 1. I'll draw another fraction and shade in 3/4. That's 2. Sorry, I'll make them as even as possible. That's 3. And that's 4. So this is my quadrupled recipe. If I had like a 3/4 cup measuring cup, I could fill it 4 times and then I'd have enough. So how much total milk did I use? Well, 3/4 4 times is the same as how many fourths. I'm actually going to count up how many shaded in fourths I have. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this is kind of cool because I haven't shown you guys this yet, but this is called an improper fraction. If I write the number 12 on top of 4, it's strange because 12 is larger than 4. So when the numerator is bigger than the denominator, it's called an improper fraction. And that's totally fine. It just means I have 12 fourths. I have lots of wholes, basically. And I just cut them up into 4 pieces. So this is called an improper fraction. When the numerator is larger than the denominator. And that's totally fine. This is a great answer, 12/4 in fact. If you had given me this answer, I'd be like, you're on it, perfect. If, however, you wanted to think about this in terms of how many actual wholes you have, there's a couple ways you could do this. Some of you know that 12 divided by 4, right? We can just divide them, equals 3. But that's kind of a tricky thing, and let's actually visualize it. So here's what I think about. If I take these fourths right here, and I take one of the fourths and shade it in here, and one of the fourths and shade it in here, my second hole, and this fourth here and shade it in here. So I basically just took these and I almost like redistributed them. So this guy is crossed out, and we've moved him. We took these fourths and we actually moved them to the other fourths. How many filled in holes do I have? 1, 2, 3. This is 4/4, so it's 1 hole. 4/4, 1 whole, 4/4, 1 whole. So I actually, instead of having 3/4 4 times, I have 3 whole cups. Pretty cool, right? I love fractions. I wish I could teach them to you in person. Anyway, I keep complaining about that. I'm sorry. So we'll just do the same exact thing with our half of butter, and that's actually even easier because you guys know how to work with halves so easily. So I have a half 4 times, otherwise known as 4 times 1/2. I'm actually going to write that equation because you're going to notice something really cool about how we multiply with fractions. So I'm just going to draw my halves. 1, 2, 3, 4. So I have quadrupled my halves. I have 4 halves, right? 4 over 2. So 4 times 1/2 is the same as 4 over 2. Notice, the 2 doesn't change. I didn't change these into 4ths. I didn't change these into 8ths. I didn't change these into 16ths. They still stay as halves. I just have 4 of them, right? If I have 4 half sticks of butter, I'd say I have 4 half sticks of butter, right? And I could go and grab that for you, but that would be kind of weird. So I'm not going to do that right now. But 4 halves, right? Now I could take those half sticks and I could stick them together and make whole sticks, just like we did with our quarters over here. So instead, if I don't want to have this improper fraction, I want to see, well, how many wholes do I have? You guys are going to know this ahead of time already, but I will show you anyway. I'm going to cross out and remove. I'm basically going to take this guy right here. I'm going to move him and shade him in up here. So, okay, that half is done. Now I have 1 whole. I'm going to do the same thing with this half over here. I'm going to shade him in, and I have 2 wholes. So interesting. We can take a fraction and we can write it as an improper fraction, right? A large number on top and a smaller number on the bottom. We could also change it into how many wholes we have. So for this answer, for the first problem, part 1, we had 3 cups of milk. 3/4 times 4 would be 3. And 4 times 1/2 of butter would be 2 whole cups of butter. So I know a lot of you guys worked on this and showed different versions of models. This is awesome. I think I was really impressed with what you guys came up with. I'm going to erase a little bit. Sorry, wait for my thing to dry. And do part 2 with you. And maybe even part 3. A lot of you did not try part 3, and I'm kind of upset about that. If I give you a challenge, it's there for a reason. But it's okay. It did say optional. I can't be too upset. I know some of you have a lot of work to do. All right, sorry guys. So, let me take a swig of water. Talking to myself too much. I sound like a crazy person. And obviously, if you're like, I don't understand what you're saying, Miss Eminelli, you sound crazy, come to office hours. Tell me. I'll have a Zoom with you. I'm totally fine with that. I love teaching fractions. You know that. It's hard when I can't actually give you things to touch, so please, work with me. All right, so, part 2. If Miss Eminelli has 2 cups of milk, now this is assuming the 3/4 cups of milk from the first part, like it's the same recipe, does she have enough to double the recipe? If yes, how much will she have left over? All right, so I have 3/4 cup for one recipe, so now I'm just going to double that. I'm going to do 3/4 times 2. So I'm still going to draw it out because I like to draw my fractions. It's new. Let's draw. Drawing is kind of fun. So I'm going to do 3/4 2 times. I'm going to draw it right here. 1, 2, 3 out of 4. I'm going to try to make my holes as much the same as possible because, of course, I'm dealing with like the same size hole, same amount of stuff. 1, 2, 3. 1, 2, 3. So how many fourths do I have? Let's count them. 1, 2, 3, right, we knew that. 4, 5, 6. So 3/4 times 2 would be 6/4. You know what the name of that fraction is. When the number on top is larger, when the numerator is greater than the denominator, it's called an improper fraction. I know you know that because I just told you. And that's fine, but wait, I don't know if that's less than 2, or do I? Right here, I just drew 2 holes, didn't I? 1 hole, 2 holes. They're not all filled in. So do I have more than 2 holes or less than 2 whole cups? Yeah, less. I'm sure that's what you just screamed at the machine at me. Screamed at the screen. Screamed at the screen. That's so hard to say. Screamed at the screen. So instead of having 2 whole cups, I only have 6/4, which is less than 2 whole cups. What's missing? 1/4 and 1/4 right here. So 2/4 are needed or left over of my 2 wholes. Another way you could visualize that, in case that's kind of tricky. So like, yes, she has enough. She has 2/4 left over. Again, let's make a whole, right? I don't like to deal with things that are like not filled in holes. I like to make a whole and then have some leftovers. So I'm going to take one of my 4ths from here. I'm just going to move it because it's the same size, same amount of stuff. And now I have 1 whole and 2/4, or 1 1/2, right? Because like half of it is filled in. So I'm using 1 1/2. That 6/4 equals 1 2/4, right? 1 whole and 2/4 left over. And we're going to talk about these types of fractions later on. Don't stress. I know you're kind of familiar with them a little bit. So I'm using 1 1/2, or 1 2/4 equivalent. And I would have 2/4 left over that I did not fill in. So right, I've got 1/4 here and 1/4 here. Make 2/4. Cool? I hope so. That again was kind of tricky. It required you to pay attention to 2 parts of the problem. I understand. Now, part 3. The recipe, I'm going to shout out Ellie and Mason because they both did this and they did a really good job. The recipe also requires 3/4 cups of sugar. Miss Eminelli only has a 1/8 cup measuring cup, right? So like, I don't have a 3/4 cup, I only have 1/8. Can I make 3/4 of 1/8? Sure, absolutely. How many 1/8 are needed to fill 3/4? If you were on my Zoom this week, you saw we can take a 4th and change it to 8ths very easily. I'm going to draw a big giant rectangle over here. I'm going to cut it into 4ths. 1, 2, 3, 4. I'm going to shade in 3/4 because that's what I need. I'm going to use my blue actually, so you can see it. Now, if I cut down the middle, I have just changed 4ths into 8ths. Still the same whole, right? The big giant rectangle did not change. But I have 1, 2, 3, 4, 5, 6, 7, 8 pieces now. So 3/4 equals how many 8ths? What's shaded? 6, right? 6/8. So I would need 6 1/8 cups of sugar. Basically, I'd have to use it, I have to fill it 6 times, right? Like 1/8, 1/8, 1/8, 1/8, 1/8, 1/8, until I had enough. That wasn't actually that hard. I put challenge on it, but it wasn't that challenging. Cool. So this is kind of like an equivalent fraction idea. When in doubt, if you draw this, this does not have to be complicated. I've taught fractions lots of times, and every time that kids draw things, they are so much more successful. But you will not draw circles. I know, because you'd be honest with me, and you would not go against that. I hope this was helpful, and if you need help in office hours, I will be available. Just sign on up and join me. I'd love to see your faces. Happy Friday. Enjoy your day. Bye, guys.